Hey, this is Physics Lab 1, in which I observed an object moving at constant velocity, which is constant speed and constant direction. The object that I chose to observe was a roll of duct tape moving across a flat ground, and I analyzed my observations using Tracker, and I also made a computational model using VPython, and I compared my two results and analyses. And the fundamental principle that we're working with here is Newton's second law, which says that the final velocity equals the initial velocity plus the net force divided by the mass of the object times the change in time. And here is my first observation. So here you can see the observed object moving towards the right of the screen. It follows along with the x-axis that I oriented such that the object starts at its origin and the positive x direction is towards the right of the screen and the positive y direction is towards the top of the screen. The movement is captured in this graph in this table. It starts at time equals 0 seconds and ends at time equals 0.625 seconds, and the x units also are shown. And these values are here plotted on this graph. You can see that only a small portion of the actual footage captured was used for the analysis, and this is because I needed to find or use an object traveling at constant velocity, which would mean I would try to cut out the parts where the object was accelerating and where the object was decelerating. Here's the coding that was used on VPython to get the computational model with the predicted position versus time of a ball. The updates that were made was the ball's initial velocity and position, which was gotten from the actual real-life observations from the tracker video. Also what was changed was the actual physics of the ball. The ball's final velocity was adjusted so that it followed Newton's second law, and its F net, its net force was 0, 0, 0, or the zero vector, because it was moving at constant velocity. And so if I run this module, so the module looks very similar to the actual movement of the tracker video of the observed ball that I captured on video. VPython and the tracker analyses and put it into this graph right here. The red line right here represents the model data, and the blue dots represents the observed roll of tape, the experimental data. You might note that the same values were used for the model in the early stages to be able to put in a initial velocity for the model, and then over here there's some little bit of deviation from the model or the prediction or the predicted position, and this might be explained by some net force that wasn't accounted for. All that I said that I oriented the axes in the tracker video so that the positive x direction was that way and the positive y was that way, and produced this graph over here. If I were to switch these axes so that the negative x direction was going that way and the negative y direction was going that way, then this graph would simply be flipped across the x-axis and it would be going downwards like that. And this is because the object would be moving towards the negative x, and the x is a position in meters, and it would just be going negative or towards the left as a reference to the normal coordinate system. And since the object is only moving horizontally and not vertically, the y coordinates do not matter at all. Also, you might notice that the velocity is constant, and that is because the net force was essentially constant, and that means that I can conclude that the force is canceled out, and that would be the force from the push of the object, the air resistance, the friction from the ground, and somehow these all canceled out, and the cancellation of these forces is calculatable, but I'm not yet knowledgeable enough to do this myself, but it can be done. Quick recap, this entire video is about Newton's second law, this principle right here, and one of the main points that I learned today was that if the final velocity equals the initial velocity, aka there's constant velocity, then we can go ahead and conclude that the net force on the object equals 0.